Oh, really? Okay, good. Very, very, very good audience. Amazing. But it turns out most people think that what they do on a blockchain, cannot be traced back to who they are, and so it's completely fine to do everything publicly. But it's not exactly true because, obviously when you inspect the actual transactions, well, you can find out a lot of things about people. And it turns out that some companies are even offering services to governments to help them re-identify wallets. So it doesn't matter how much you think and you try to be anonymous on a blockchain, the fact that everything is public means that there is always going to be a way to basically trace it back to you. And that's a very, very, very big problem. It's a problem, of course, because of surveillance, but it's also a problem because more and more you have criminals which are literally just looking at how much money you have, and they're like, oh, I know where you live, I know where you work, I know how much money you have. Well, maybe I'm going to try and steal your keys. And this is not anecdotal. I mean, we hear about some of them in the press, but I know at least a couple dozen people that had, if not a gun, a knife put to their throat, asking them for their private keys. So clearly, I think, we need a solution for that, because if we keep on doing everything publicly, we're just going to take more and more risk. I think there was a paper that came out recently that says that the richest people in crypto are actually living in hiding by fear of being targeted by criminals. So that's a real problem. It's not about fraud anymore. It's really about literally not dying. Companies also use it to monitor the competitors. It's quite amazing when you think about it. Imagine if you're running a mobile app and every single user was known to your competitors. Every single click on your application was known to your competitors. Every single action people did on your product was known to your competitors. That would make it pretty easy for people to copy what you're doing, throw in $100 million more in marketing, and basically beat you in terms of user adoption. And that's basically what happens in the blockchain. Because everything is public, there is no way to hide how popular or how your application is actually working. Again, you would really never think of doing that in a traditional setting. Another big problem is trading. Maybe you've got a great idea for a trade, or maybe you have an arbitrage opportunity. Well, it turns out that because people can actually monitor the pending transaction in something called a mempool, they can actually trade it before you do. So, if you place a trade, someone sees that it's a good trade, they'll do the same, just put more gas fees so that they're executed before you are. That's called front running, which is obviously legal in traditional markets, but I don't think it's illegal yet in crypto. Because everything is public, it's very easy for people to do that, and that's a very, very, very big problem. How can you actually trade without being visible? I mean, you can do it on a private centralized exchange, but if you do it on a decentralized exchange, everything you're doing is actually visible before it gets executed. So I think, it's fair to say that the idea of everything public on a blockchain is not really something ideal. It's the only solution we had so far, but we really, really want blockchain privacy. What we really want is decentralized, consensus-based networks that enable to do all the things we're doing today, transactions, smart contracts, and all these things, but do it in a way that's completely private and secret. Nobody should actually see what we're doing or know what we're about to do. The problem is that there is a kind of blockchain trilemma. When you look at the various blockchain solutions, you kind of have to pick 2 out of 3 between scalability, functionality, and privacy. So for example, if you want to have functionality and scalability, that's what most layer 2s are currently trying to do, using zero knowledge or that kind of stuff. That's great, because you can do a lot more transactions per second, but none of them are private. They're still public. Everything is still visible to everybody else. So some people worked on another piece of this triangle, which is scalability and privacy. Let's try to actually send money to other people without being known. Many projects exist around that, Zcash, Tornado Cash on Ethereum, ZK Money. The problem is that it's very limited in terms of functionality. You can send money to people, you can maybe do a couple of other function calls, but you cannot actually run a full smart contract platform in a complete private way. But people did figure out a way to do private smart contracts, and there are existing networks today, for example, such as Oasis, Enigma, Secret Network, that actually enable you to do private transactions and private smart contracts. So you could think, oh, well, they do solve the triangle. Well, not exactly, because the technology they're using, first of all, isn't as secure as you might think. It's using something called SGX, which is a hardware security element. And also, it hasn't been proven to scale to the kind of application people want to do on L2s today. So that's a really big problem, because until we figure out a way to combine scalability, functionality, and privacy, we're going to be stuck using public blockchains for at least some of the things we're doing. And I think it's fair to say that it's not really something that's desirable. So there's a new type of technology which is actually starting to work and coming up soon, which is called homomorphic encryption. So homomorphic encryption is a new type of cryptography where you can actually do computing on the encrypted data itself completely blindly. So if I'm a user and let's say, for example, I want to access some kind of a photo filtering app. I'm going to give you a Web 2 use case for this. Let's imagine I want to use some kind of photo filtering application. Traditionally, what I would do, let's say Instagram with a filter, I would take my picture, I would encrypt it on my phone, I would then send the encrypted picture to Instagram's servers. They would then decrypt it, right, because they need to see my picture to do something with it. Then they would apply some kind of filter, re-encrypt it, and send it back to me. What that means is that you have privacy during the transmission of the data, but the server, so the actual node doing the computation, can see your actual picture and your data and everything that's happening. And as a result, you know, there is basically a database of users' data that's actually sitting on those servers. And you can think of the same thing actually in a blockchain. You know, whenever you do a transaction, you're effectively sending data to a server. The problem is that in this case here with Instagram, only Instagram supposedly has access to your data and to the data of users. In the case of a blockchain, everybody has access to it. So that's a big problem. So with homomorphic encryption, you could actually do all of that encrypted end-to-end. So the way it would work is very similar, right? So you basically have your mobile phone, you take a picture, you encrypt it, and you send it to the cloud for processing. But this time, it was encrypted using homomorphic encryption, which means that you can actually manipulate the data without decrypting it. You can apply the filter without decrypting the data. In fact, the server doesn't even have the decryption key. This is never sent in the first place. Sends back the response to the user, who can then decrypt it on their phone. So from the user's perspective, everything is exactly the same. You're sending data and getting a response, but now the data is not just encrypted in transit, it's also encrypted during processing. So it's encrypted end-to-end. And as a result, the server doing the computation doesn't have any information on the users or their data. Everything is encrypted. So a government could come and could say, give me access to your database. It would be irrelevant because the only thing the government would have is a bunch of encrypted user data that they would need to go to every single user independently to be able to decrypt, which obviously is not realistic. So now put that in a blockchain setting. Replace Instagram server by, you know, a miner doing the smart contract transactions, right? So the user would basically send an encrypted private transaction from an encrypted address. So the miner has no idea who makes the transaction. They have no idea what's included in the transaction. And as a result, you can actually get private smart contracts and blockchain privacy. So that's basically a way with this technology where you could hide who you are, hide what you're doing, and keep everything hidden from the public at all time, and still have all the functionality of a blockchain and smart contracts because of this property that you can actually do compute on the encrypted data. So this is pretty revolutionary, and it's not a new technology. It's something people have been working on for 40 years, something like that. The problem is that it was never actually useful in practice because it was too slow. And by too slow, we're talking about 1 billion times slower than doing the same operation without encryption. Good idea, but if something that used to take you, you know, a couple of milliseconds now takes you 11 days, it's not exactly user-friendly, even in a blockchain setup where things are already quite slow. Fortunately, this is actually completely changing because there are people that are working on making homomorphic encryption much faster thanks to dedicated hardware acceleration and other techniques. Just like Bitcoin mining has dedicated chips doing the mining faster, homomorphic encryption is starting to have dedicated chips making it faster. And what this means is that by 2025, the performance of homomorphic encryption will be such that you won't actually be able to notice the latency. And when that happens, it means you're able to do everything you're doing today on a blockchain, but encrypted end-to-end without having to ever worry about anything. And so that's why, you know, I mean, I'm personally very excited about homomorphic encryption because I work on that, obviously. And because it solves, you know, this privacy trilemma in blockchain, where for the first time you can really have privacy, scalability, and functionality at the same time. So nobody knows we're working on that, by the way. So my company is very, very under the radar. You know, we've raised 50 million already so far in the last couple of years. We're going to be announcing some of the work we're doing on blockchain probably in a year. But I figured it's important for people to know that this is possible, that this is no longer, you know, a hypothetical scenario, that this is possible in practice, and that is probably going to be coming out in the next couple of years. So why do I care about all of these things? You know, privacy is something I've been working on for 15 years now. It's something I've always really cared about because, you know, when people think about the future, they think about this. They think about, you know, this is from the fifth element. They think about a world where technology is, you know, very present, where there is policing everywhere, advertising nudging you, where basically you're being manipulated on a constant basis because people have access to your entire data and your entire life. But I don't think it has to be this way, because the only reason it's this way is because people know what you're up to and what you're doing, right? But if people actually didn't know, you know, what if you didn't have to care about surveillance? What if you didn't have to care about, you know, data breach, or about, you know, a criminal targeting you because they know how rich you are? What if you didn't have to care about companies actually competing you? Well, I think in reality, it would give you a lot of peace of mind. You know, and this is the real promise of privacy. The point of privacy is not to have you worry about something else. It's actually to have you not worry about any of those things, which are problems today, so that, you know, eventually you can spend your day thinking that you're at the beach. So thank you. I hope you guys enjoyed it. I think we have a little bit of time for questions. And if you'd like to read a little bit more about these things, I have a Substack that you can actually follow. You know, I also post some deals if you guys are interested in investing as well. Thank you. Great. So we have 7 minutes for questions. Anybody has a question? Wait, just the mic, 1 second. So I'm giving you a bit of like the cutting edge of the cutting edge of the cutting edge of cryptography. It sounds simple, but this is horrendously complicated not to actually make work. So don't be fooled.
So can you dig into the details of homomorphic encryption? Why is it slow, and what are the? I suppose there are many like particularities or things you have to think about, or restriction when you do computation on it. So just curious about what these are.
So it used to be through a convert for Python or Rust code into homomorphic operations directly. So as a developer, you don't care about the cryptography anymore. You just write your smart contract. Actually, it could be Solidity. It doesn't really matter what language you're using. So that's also solved. The only thing that remains is pure performance, which, as I mentioned, is a question of hardware acceleration, which many companies, including Intel, are currently working on and will be shipping in the next couple of years. So that's why I'm saying homomorphic encryption is one of those things that people don't realize is working and is so close to being a mainstream technology. But think about it, you know, like it's I think from Web 3 to Web 2, everybody benefits from that. Like if you're a company doing software as a service in the cloud, why would you not do it encrypted? Like there's no benefit in having the data when you're just offering a service using the data, right? Think about, as I mentioned, you know, the smart contract. Think about biometric authentication. You know, why should a company have your face if they can actually authenticate to encrypt it? So there is like a zillion of use cases for that. On the math side, if you're interested in learning more, we actually have a monthly meetup called FHE.org. FHE stands for Full Homomorphic Encryption. So it's very technical, very math and code heavy meetup. So definitely not as high level as what I presented here. But if that's what you're after, FHE.org is the right place to go. Yeah.
Thank you for the presentation. Actually, I have a question. What is the main difference between the zero-knowledge proof techniques and the homomorphic encryption? Thank you.
So, yeah, I mean, the two are complementary, right? The idea of a zero-knowledge proof is to prove that you've done something or that you own something without actually telling people what you own or what you did. So it's not that you're doing the actual computation in encrypted data, it's that you're proving that you did what you're supposed to do, right? So for example, there's a company called Starkware, which is really good, by the way, at zero-knowledge stuff, to prove that a smart contract was executed correctly. They actually look at the execution trace in your computer of the actual smart contract, and they match that against a kind of cryptographic signature to verify that, oh, you know, this kind of execution sort of like a trace is correct because it fits the signature. But the actual execution was still on regular data. The data wasn't encrypted, right? But you could use the same technique, for example, to also say, I can pay you without, I mean, I can tell you I can pay you, so I can prove I can pay you without actually you seeing my balance. So that's what zero cash, like Zcash and stuff do. Homomorphic encryption is different. Homomorphic encryption says, okay, give me your data. Your data is encrypted, so I have no clue what you just gave me, but you did give me the data, and I'm computing on it. So really, you know, one thing I didn't mention here is this blockchain trilemma actually requires most likely zero knowledge and homomorphic encryption, because you still want to prove that the encrypted computation was correct. Because otherwise, if you're going to pay a miner to do a computation, you still want to make sure they're correct. So either you do this with consensus, or you do this with zero knowledge, both of which are options. I prefer to use zero knowledge. It's less costly than consensus, but you know, we'll see what we can actually build.
A quick question on the limits of homomorphic encryption. You're fairly still limited to transformations, though, right? You can't do query results because you'd end up with the same. You know, if you can keep querying it over and over again, you can effectively infer the data behind the scenes. So it's would you say it's primarily transformations is the kind of the set of problems?
So the user is the one who encrypts the inputs and decrypts the outputs. So of course, you know, if you let a user query a database that's encrypted and decrypt anything in it, then he's going to eventually be able to see the whole database. But hopefully, you know, this database should have some kind of access control, right? So you could actually have homomorphic signatures. So you could actually ask the user to send an encrypted signature to prove it's him, and you would basically filter the database based on the user's data that's in it, and then only return that. But that's more of like an implementation problem from the developer. So if the developer fucks up the implementation, there's nothing you can do about it. That's, you know, that's just the developer who didn't do his job. And that's true of every cryptography protocol, by the way. There's always an assumption that the implementation is correct. Which is easier, by the way, in homomorphic encryption, because at least there is no private key on the server. But still, you know, this is an example of a potential data leak. But yeah, but I would say homomorphic encryption doesn't change anything to that. It's just the application needs to verify that. So in the case of a blockchain, obviously that would be important, because you want the user to know their own balance and assets, but you don't want them to know the balance and assets of other people. So you do need that kind of implemented, I would say, filtered querying system. We have 1 minute left. Any other question? Final question? Yeah. Someone else before, maybe we have another question. Okay, go ahead.
So yeah, regarding to the doxing you talked about before, I'm not very sold on encryption being the solution to that, because like if you're wealthy and just talk about it, then you dox yourself, and then the encryption is not going to do anything. So
well, I mean, if you drive a Lamborghini, well, first of all, you could rent it, so it doesn't mean you own it. But assuming you do own it and you pretend you own it, then you're just asking for it, right? This has nothing to do with the blockchain, but at the end of the day, people wouldn't know how much you have. The problem with cryptocurrency, like if you show that you're wealthy in the real world, that wealth could be regular cash. It could be other stuff.
But let's take some obvious example. Let's take CZ, for example. If he uses encryption or not, people can just guess. So
no. They wouldn't know which address belongs to him. That's the thing.
Yeah, but there's this XKCD with the, like, you can try to break the encryption, or you can kidnap the guy and just beat him with the wrench.
Of course, because
that will always work.
Of course, because he's publicly known to be wealthy. But many people in blockchain are not public figures, right? People don't know who they are. And, you know, they don't want to know how much they have. I mean, I have some stuff on my public address, but I have just enough to basically make sure that if someone do put a gun to my head, like, they get away with something, but not everything. Everything else is like in a multi-sig and everything, and you have to break into 5 different banks to get the keys. But, you know, that's what you should do, and probably CZ does the same thing.
Yeah, I agree. I mean, my point is there's more than just encryption you have to do to solve that problem effectively.
Well, yeah, I mean, okay, so don't be a public figure. That's basically the bottom line. Okay, great. Well, thank you very much, everyone, and speak to you soon.